Lehman. Yeah! Hi, everybody. This is Mrs. Lehman from Math with Mrs. Lehman. These kids are wonderful. They just did a great little math jingle. Um, so, anyway, we have a bell ringer here today. What is the area of the triangle? And we have a triangle here that has a height of 5 and a base of 13. So, what is the formula for the area of a triangle? Stephanie, nice and loud, please.
Base times height over 2.
Very good. Base times height over 2, which means divided by 2. So base times height divided by 2. We're going to plug in what for our base, everybody?
13.
And our height is 5. And then we divide that by 2. 13 times 5 is 65 divided by 2. So we're going to get 32.5. Now, for area, what unit would we have? Yep, centimeters squared. All right, so that is the answer to that. Who here had 32.5 centimeters squared? Nice job. All right, the next one is a little bit tricky. Math wizards love this question, or questions like this. It says a parallelogram has an area of 168 square inches, and it has a height of 12 inches. What is the base? So we know the area formula for a parallelogram is what? Michael?
Length times width.
Now that's for a rectangle, but any parallelogram would be
Base times height.
base times height, yeah. So, base times height there. So what can we fill in for area here? Cassie, nice and loud.
168.
Very good, 168. A lot of kids aren't expecting to be given the area, so they just plug it in for the base and height by accident, and they make mistakes there. So if it gives you the area, you plug it in for the A, and then we have a height of 12. Now, I don't want to write this because it's kind of sloppy math, all right? I'm going to switch those two things around. I'm going to say 12b. And what do we call that 12 when we have that in front of a variable? Aiden.
Coefficient.
Very good. And what property tells us that I can switch it from b times 12 to 12 times b? What property of multiplication tells me that? Caleb.
The commutative.
Very good. The commutative property. Nice job. So we want to get rid of this dividing by, I'm sorry, I just gave it away. This multiplying by 12. So the inverse of multiplying by 12 is dividing by 12. And you have to do the same thing to both sides of an equation. So that's going to cancel out. So you're going to have b equals 168 divided by 12. When you divide that, what should you get? 14. Very good. So 14. Now, it's asking for the height. Would we measure height in inches, inches squared, or inches cubed? Just inches. All right? Because when you go to get your height measured or you measure the length of something, you're just talking about inches, not how many square inches you take up. All right? And you're not a flat person, right? Flat Stanley could get surface area figured out. But anyway, yeah, a little off track there. We're gonna go over your homework after we do the math joke of the day. Today's joke says annoyingly right triangle, or right angle, I should say. What did I tell you? Admit it, you were wrong. I hate to say I told you so, but he's always right. Yeah, everyone knows a person like that. They have to be right all the time. Anyway, and it's annoying. Moving on. Yesterday we did some of this, and so I kept it up here on the smart board. We did volume, and we dealt with fractions a lot. So we know that volume equals length times width times height. We talked about how another way of saying volume or calculating volume is taking the area of the base. So if the length and the width are already multiplied for you, that's going to give you the area of that base. And then you multiply that by the height. You'll notice that this is a capital B, right? So in the math world and math lingo, that's reserved for very specific things. Like a capital V is for volume, capital B is for the area of the base. And this is the area of the rectangular bars. I'm going to write E there. I'm not sure how that got erased. But anyway, Another thing we talked about yesterday is when we were talking about volume, it's talking about the capacity of something or how much space something takes up. And a common math question that you'll see when you're asked to do volume, instead of saying what is the volume, then we'll say something like this. How many 1 inch by 1 inch by 1 inch cubes will this hold? All right, so if you were to chop it up into tiny cubes, how many would you have? How many could it hold if this were a box of this capacity? All right, so it's a fancy math wizardly way of saying what is the volume. All right, so we calculated these two. We said that the one on the right has a volume of 480 versus the one on the left, which was 240 inches cubed. All right, today we're going to talk about this one. And we are going to kind of dive into something a little challenging here, but I would like to go over your homework before we get to that. All right, so if you guys could go to page 41, this was your homework. We had to calculate the volume of the following rectangular prisms. So I've already gone around and checked the kids' homework, and a lot of kids did a really great job with writing the formula. So whether you're finding the area or the volume of something, you really need to start with that first step, which is your formula. So just so you know what I'm talking about, that's what you do. So that's a volume formula for a rectangular prism or a rectangular solid. This would be your second step, which would be to plug in the numbers that you see here, here, and here. And your third step would be to then put them in a form that we can operate on. All right, so before we start operating on these numbers, we are going to change the mixed numbers into improper fractions. So if you need review on that, you take your bottom number, your denominator, you multiply it by the whole number. So in this case, 4 times 2 is 8. 8 plus 3, you add that numerator, you're going to get 11. Keep the same denominator of 4. All right? Any questions on how I converted that into an improper fraction? All right, again, that should be review for you. 1/2, we don't need to change. I had a lot of kids earlier in the day try to change it into 2/4. Now, mathematically, you're not changing the value of anything, but it's unnecessary. When you are multiplying fractions, you do not need to have a common denominator, which is why some kids had that misconception. Well, some kids had that misconception, and that is why they went and changed it to 2/4. You're wasting your time, okay? You do not need to do that. When you're multiplying, you just multiply straight across. You do not need a common denominator. So anyway, this 1 1/4 would be 5/4. 11 times 1 times 5 is 55, and then you get 32 when you multiply across the bottom. A lot of kids had that part of the answer, and then something went haywire when we got to this next step. So what you do is take the numerator divided by the denominator. Like up here, I have 55 divided by 32. That's going to go in one time, and then you're going to subtract. You're going to get 23 left over. So that 23 is your numerator. 32 is your denominator. So your answer for number 8A, the first question of your homework, was 1 and 23 32nd centimeters cubed, or cubic centimeters. All right, any questions on that? I saw a few papers where kids did not label their answer. Make sure you're adding that label. Again, volume is in cubic centimeters because we're multiplying centimeters times centimeters times centimeters. All right, the next thing that we're going to do is review part B of question 8. That was the second question of your homework. Same thing. Step 1, write down the formula. Step 2, plug in. Step 3, get it in a form that you can operate on. In this case, we need to take 3 1/3, change it to 10/3. We do that for 2 of the sides because they're the same as a square base. And then we have 5 2/3, which would convert to 17/3. When you multiply straight across, you're going to get 1,700. And then 3 times 3 times 3, I had a lot of kids put 9 down. Or a lot of kids put 3 down, again, thinking like the addition rules of adding fractions where you would keep the same denominator if you had that common denominator straight across. But this is multiplication, so you're just going to multiply 3 times 3 times 3, which is 27. Right when you divide that, I'm just going to save us a little time. I did this on a calculator. 62 is what you would get, but you would have 26 left over. So that would be your numerator out of the original 27. All right, and again, you would have inches cubed. Do you have a question? Do you want me to pause the video, or you're okay? No, I can pause it. Please hold. We're going to now continue by looking at a case that you'll see a lot of times, and that is when you're given the base. So there's a lot of pages to this lesson, and a lot of which we are going to skip. So I'm going to erase some of this stuff because so I guess viewers at home, you can just watch me erasing stuff on the smartboard. I'm sure that's why you subscribe to my channel, to watch me erase things virtually. The page is 47. Alright, so tonight I'm going to have the kids do part B for homework. We're going to do part A together right now. So we have a sandbox right here. So I'm sure that takes you back to your youth, right? Who here has played in a sandbox before? It's pretty exciting, right? A sand circle, a tire. Anyone have a tire sandbox? Okay. Who just played on the beach? You lucky kids. All right. We're kind of short on beaches here. And a sand turtle, yeah. So, is it little tykes, I think? There you go. People get creative, and that's cool. But anyway, this is a sandbox. It's pretty basic looking. Yeah. So what we have is this question that says the area of the base of a sandbox is 9.5 feet squared. So they're giving us the area of the base, right? And the volume of the sandbox is 7 1/8 feet cubed. Determine the height. So to read that again, the area of the base is 9.5 feet squared. The volume is 7 1/8 feet cubed. We are determining the height of that sandbox. So I always say to start with what you know, okay? So we know the formula for volume is length times width times height. Now the problem with this is we don't know the height. We do know the length, or no, I'm sorry, we know the volume. We don't specifically know the length and the width. But there's another formula that we can utilize here. And I believe I taught you this yesterday. We can use a capital B times H, right? We talked about this at the beginning. And that means some of the work has already been done for you. When they've already multiplied the length and the width, that's going to give you the area of maybe what you use as that bottom piece of wood for that sandbox, right? So they're telling you the area of the rectangle. Does that make sense? That is going to be what they're calling B, which is very difficult to see on that. Maybe I should color this, color this in with a different color. So I'm getting a little bit ridiculous about this at this point. But anyway, so you got a rectangular base here, right? That's just a flat board at the bottom, right? You're picturing the flat board at the bottom? All right, that you would call the base of it, okay? So on a Kleenex box, that was like the rectangle that I showed you at the bottom, right? That's the base of it. Now that's not accounting for the height. There's the height. We have the width, we have the length, and we know when we multiply the width and the length, you're going to get that base area. But we still don't know the height. So we're going to plug in what we know, figure out what we don't. So let's start with that formula. Volume equals capital B times H. And they've given us a few little golden nuggets of information here. What can we plug in for the volume? Because they told us the volume. Michael?
7 1/8.
Very good. So instead of V, we're going to write 7 1/8 equals, and then the base, capital B, the base. So what would that be? Emma? Very good. Emma, 9 1/2. So we're still missing the height, but we've plugged in everything that we do know. So next step, same as we did earlier, you set up your formula, then you plug in the numbers that you've been given. Third step is to convert these into improper fractions. Yep, so 7 times 8 is 56, plus 1 is 57. So we're going to have 57 eighths equals, and then 9 and 1/2, what would that be as an improper fraction? 19 halves, very good. So 19 over 2 times h. Now, this really, would be easy if they were whole numbers, right? But we're dealing with some fractions, so there's a few other tricks that you need to know. So we know this is what type of equation currently?
Improper.
No, it's a proper equation. Those are improper fractions. But what operation's going on between the h and the 19.2? Multiplication, good. So we want to do the inverse of multiplication just like we would if they were whole numbers, right? So instead of multiplying, we want to divide. So we're going to divide by 19 halves, all right? So when we divide by a fraction, do you guys remember the saying for that? It's 3 steps. Keep, change, flip, or copy, dot, flip. So, I've got the number already written there. I'm going to dot it and flip it now. All right, so what is the reciprocal of 19 halves? 2 19ths, very good. So we're going to multiply each side by 2 19ths, all right? This is where a lot of cancellation goes on, right? So if you have numbers diagonal like this, 19 and 19, we can simplify before we multiply, right? They cancel each other out. This 2 and this 2 will cancel each other out. So now we're left with h equals 2 19ths times 57 eighths. All right, so again, we're going to look diagonally. So in this case, here and here, to see if there's anything we can simplify. 2 and 8 have a common factor of what? No? 4? No, not 4. 4 is not a multiple of 8. 2 is the common factor. It's a number that will go into 2. It'll also go into 8. So 2 divided by 2 is 1. 8 divided by 2 is 4. I hope that's what you meant when you all shouted out 4. Oh, that is? Okay. Whew. Oh boy, don't correct me. Just tell me yes. That's what you meant. Alright, so then we have this and this that can actually simplify, and just to save some time, 19 is a factor of 57. 19 goes into 19 1 times, and it goes into 57 3 times. So we have 1 times 3, which is what? And 1 times 4, which is 4. So we want to say that the height is 3/4. Now think about this. What do we measure height in? Do we measure it in feet, feet squared, or feet cubed? Think about it.
Feet.
I'm hearing every answer. Just when you go to the doctor, they don't say you're 5.5 feet cubed, right? They're measuring your height, which is just a distance, right? So it's going to be just plain feet. So 3/4 feet. All right, so again, just like that bell ringer question where you were given the area of the parallelogram, it's kind of the same thing, except for now, they're giving you the volume. You have to work in reverse to figure out your unknown pieces. Does that make sense to everyone? All right, what we're going to do today is a little bit tricky, and we're not going to have a ton of time to go over it, but this class will definitely want this info. So let's go to the first page of this lesson, which was page 39, right? So on page 39, we found the the volume of 2 different rectangular prisms. We found out one to be 240. We found the other one to be 480 cubic inches. So down here, they changed the question a little bit. They have a box that's the same size as the one given up top on the left. And it says a box with the same dimensions as a prism in the opening exercise will be used to ship miniature dice whose side lengths have been cut in half. The dice are 1/2 by 1/2 by 1/2 inches. All right, how many dice can fit into the box? Well, we said yesterday if they're whole, if it was 1 inch by 1 inch by 1 inch, right, we would fit 240 in that, okay? But now the dice got smaller, right? They got cut down to 1/2 cubes, 1/2 inch cubes. So, first of all, I want you to think, would there be more or less that would fit in there then? More. Why more? Because they're smaller, right? Think about it like you load your washing machine, right? You're loading it with towels versus washcloths. You're going to fit way more washcloths in that washing machine than you will full-size towels, right? Same with these little blocks of plastic that are dice, right? Not for gambling, New York State. And they are going to be, I'm surprised they didn't call them number cubes. Most of the time they call them number cubes because they are trying to avoid that gambling implication. But I think we're over that. So anyway, if something's bigger, you can fit less of that in this box. If something's smaller, it would make sense that you'd be able to fit more. So that should be in your mind a common sense approach as far as what your answer should be. So will our answer be greater or less than 240? Greater than, right? So we got to figure out how many times greater. So to demonstrate this, I am going to show you this little thing I made, right? So let's say, what? What do you think the answer is? You want to double it. Common misconception, all right? So I'm going to show you why that's not right. So let's say this, was that centimeters or inches? Inches, all right. So let's say this is a 1/2 inch by a 1/2 inch, right? Now, I'm going to take one of these. There is a 1/2 inch by a 1/2 inch, right? So if I doubled that, like Tori said, look, I'm only going to get 1 inch that way. How far would this still be? No, that's only a half. Remember, these are only 1/2 inch now. And this would only be a 1/2 inch. So I need more of these, don't I? 2 is not going to cut it. Oops. Let's erase that. Yes. Quadruple it. Well, we'll talk about, no, it's not quadrupling it. I gotta, hold on. Yeah, I have to be really picky in which order I do this because otherwise it gets all weird. Okay, so now a 1/2 inch plus a 1/2 inch is what? So this is now a whole inch wide, right? This is a whole inch. This is still only half, and this is a whole inch from here to here, right? So I need more, right? I can't have 4 times as many. Let's keep going. Somebody said 8. Yes, why 8? Yeah, I still have to account for that third dimension, the height, okay? I'm really proud of myself for this, by the way. Thanks, guys, thanks. So now it's an inch by an inch by an inch, which is what we would know would be, it would take 240 for this complete thing, but we had to use 8 of these to make one. So what do you think we're going to multiply that 240 by? 8, yep, so that's what we're going to do. So 240 times 8. 8 times 0 is 0. 8 times 4 is 32. 8 times 2 is 16. Plus 3 is 19. So 1,920 is our answer. So 1,920, leave a big space here, 1/2 inch cubes would fill the prism. Okay, we'll continue this a little bit more tomorrow, but in case you're watching this video looking for info on that, that's how that works. Essentially what you're doing is you're taking that bottom number, that 2, does everybody see that? And you're cubing it. You're getting 8. That's why we're multiplying this times 8. Does that make sense? Maybe a little. All right, guys. Thanks for watching Math with Mrs. Lehman. We're going to do our jingle one more time. Ready? Here we go. Yeah! Don't forget to like and subscribe. Have a great day.